All right, students. So here is your lesson for day 10 and 11. This is actually going to be your first summative assignment. Summative assignment is the one that we are going to be using to put towards your grade. Everything that you have been doing up to this point excuse me, has kind of led to our Prove It project. And our Prove It project is broken down into two parts. The first one you guys are going to do is the Earth Structure Prove It project part 1, where this is going to cover everything that we've kind of been learning up until this point. And then you're going to have a part 2 in which you're going to be talking about kind of the extension. So dealing with like earthquakes and specific volcanoes, okay? So I want to walk you through the directions on how you're going to do this. And all directions are going to be in this video. Otherwise, it's going to be too long for me to list. So if you have questions, go back and watch this video. Again, let me repeat. If you have questions on how to complete this assignment, go back and watch this video. Hint, 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 hint. All right, so we are in Canvas. You'll notice that it says day 10 and day 11. So we're going to have 2 days in which you're going to work on this, whether you're virtually or whether you're in person. The 2 days that you're going to be working on this, you will, because normally in a traditional year, it would take us about 4.5 days to do it. So you guys are going to have 2 full class periods, which is the equivalent of like 4.5 to 5 hours of work. It might not take you that long, but it might. And we want to make sure that you have time. So here is your assignment, okay? So your assignment, it's pretty long, but the nice part is it's pretty well laid out. So you are going to be using your notes. You can use your notes, okay? But what you cannot do is copy and paste. You guys understand that. You cannot go to the internet. You cannot copy and paste. We can figure that out pretty quickly. We need to have this stuff in your own words. So for number 1, and it's kind of actually this whole assignment's broken down into 3 actual parts. And after each part, you need to kind of check in with your teacher to see if you have done enough, okay? So right here is number 1, and I'm just going to literally walk you through the document. It says, explain convection current in Earth in your own words. So right here, this blank right here where it's being highlighted, you're going to use words and you're going to explain convection currents in Earth, how they work. Okay, I don't just want the definition that you got off of Savas. I want you to actually explain it. Okay, then you're going to do a part A. Part A says, draw a convection current that demonstrates your understanding of it. So draw a convection current. It can be anything. Okay, it could be an example of the drawing that you did. It can be a convection current. But what you need to be able to do is you need to label your drawing to explain what's going on. So you need to have your drawing here and you need to have labels that are explaining it. Obviously, you cannot draw in a document. It would take way too long. So what you're going to do is in your notebook, you are going to draw a really nice picture, color it. It needs to be colored, okay? And then you are going to take a picture of it and you're going to paste it here. The picture needs to be clear. I need to be able to see it. If it's not clear, we're not going to give you credit on this, okay? So again, explanation, then a drawing. Then you're going to go into density. You're going to explain in this space right here, density in your own words. Then here, you're going to draw a picture of something that explains density, okay? Again, you need to label what's going on and paste a clear picture. Color is important, so use color in your drawings. So again, explanation, drawing. Then this question is the big one. How does density relate to convection currents? Many of you who did the convection current demonstration videos, I responded with the response of how does density relate to this? That's the key. You need to be able to explain how density is relating to convection current. As this happens, then what happens? Okay. Step 3 is we start talking about plate tectonics. So you are going to, again, in your own words, explain what plate tectonics are. Then you're going to draw a picture that shows your understanding of plate tectonics. So somehow you are going to draw a representation of plate tectonics, what it is. You are going to label it, make sure it's in color, and you are going to paste a clear picture here. Finally, you're going to explain how do convection currents move our plates. So you're going to explain how they move them from one location to the other. Then if you're in person with me, you're going to come get this checked off. Mr. Eddy will have some type of virtual thing to stamp off. If you're virtual, you are going to email your teacher, okay, either Mr. Wall, Mr. Eddy, and says, hey, I'm done with part 1. I'm moving on to part 2, okay? Or I'm done with the first 3 questions. I'm moving to number 4, however you want to say it. What will happen is then your teacher will contact you and we'll try to set up a Zoom meeting or an email thing that we can check in with you where you can share your screen and we can talk back and forth. We're going to have to get used to it. It's not ideal, but we're going to make it work, okay? Again, if you're virtual, keep working until we get a Zoom meeting set up, okay? So that means keep moving. If you're in person, we will meet with you, raise your hand, and we will come over and check. Then you're going to start talking about our different types of boundaries. So you're going to explain divergent boundary in your own words. You are going to draw what Earth looks like at a divergent boundary. When we say a crosscut or a side view, this means like literally if you were to take the Earth and cut it in half, what would a divergent boundary look like? So you'd see the stuff that's above the crust and the stuff that's below the crust. So like what's happening both. Again, what would you need to do? Label and post a clear picture. Use color. Okay. B, you're going to list 2 plates. So you're going to look at a map of the tectonic plates and you are going to find where a divergent boundary is. So this is where you're going to say both this plate and this plate are formed at a divergent boundary. Okay, or are separated by a divergent boundary. So you need to have actual names of tectonic plates. C is what geographical land feature is created at a divergent boundary. So you're going to think like of the things we've learned about, what type of land feature is created at a divergent boundary. Go back to your notes. Same thing. What possible natural disasters can occur at a divergent boundary? So you tell me what natural disasters, 1 or 2 of them. Actually, give me 2 of them. And you'd explain how they could form. Okay? Then you're going to do the same thing for convergent boundaries. You're going to explain in words, your own words. You're going to draw a picture of a convergent boundary. Again, a crosscut or side view in color with labels. 2 plates that meet at a convergent boundary. And then you're going to come up with 2 geographical land features that are created. And then what are 2 possible natural disasters? So I guess up here it's 1. Okay. Same thing. We're going to scroll down. We're going to get to a transform boundary. Okay. So your transform boundary, explain it into your own words. Draw what the Earth looks like at a transform boundary. Crosscut or side view. You're going to list 2 plates that meet at a transform boundary. Again, actual names of tectonic plates. Again, what possible natural disaster can occur at this form? Explain how. Then, if you're in person, you're going to get checked off. If you're virtual, keep working. Send an email, said, hey, I'm done with part 2 or up through question 6. I'm ready to move on. Keep working. Finally, we have our last set. So you're going to talk about constructive forces in your own words right here. Then you're going to draw an example of constructive forces. It says an earth science example. So you need to draw something that's happened on the earth that would be a response or a result of constructive force. So you need to explain your drawing and how it's a constructive force. You can either do that in here or you can do it below. Again, draw, label, color, post a picture. What role does plate tectonics play in constructive forces? So you need to tell us, what role does that play? Why does it cause constructive forces to happen? Then you're going to do seafloor spreading. So then you're going to do, seafloor spreading. So seafloor spreading in your own words. What happens at the other side of the plate? This is where you're going to draw a picture. So you're going to draw a picture of seafloor spreading, and then as it goes away, so like the other side of seafloor spreading, not right where it's happening, but like way over here. What's going on way over here? Label it. Explain what's going on, and then how does seafloor spreading relate to continental drift? So you need to actually explain how those 2 are connected. Again, make sure you're fully answering the questions. Okay, you could actually do a drawing, all of those things. And the last thing that you have is continental drift. You're going to explain continental drift in your own words. You are then going to talk about fossils. So how do fossils, this is also known as evidence, help explain continental drift? So go back to what we've talked about, go back to your notes. How does that help explain continental drift and the theory of it? Then, how do some of the fossils, or how do the same fossils be found on different continents? So you need to explain how some of these fossils are found on different continents. Then we have a picture here. This picture is the last thing you're going to do. You're going to explain the above map of fossil distribution. So you notice how these fossils are distributed kind of around the world. You need to explain what's going on, and you need to explain what this tells us. Again, do that in detail. Then you're going to click the link, and you're going to submit this into Canvas. This is going to be your first Prove It project. So everything that we've worked up about are these terms right here. You're going to be putting them into your own words, and you're going to be drawing them. Your drawing should not be just a quick little sketch. You should take your time and make these look really nice with really good details. That, to me, is showing me that you fully understand the concept. If you rush through this, I'm not necessarily, or we're not necessarily going to call it good. We need you to take your time, and we need you to show a full understanding. Otherwise, we're going to tell you to go back and continue to work on this. So my suggestion is do it right the first time, and that's going to be a good step for you. So that's it. That is your directions for your Earth Structure Prove It project part 1, where you will be taking everything we've learned so far and showing us that you understand it. Have a great day. Good luck. If you have questions, ask your teacher. If you're virtual, email right away so we can get this hammered out. Good luck, and we will talk to you soon.